Hello friends, this video is brought to you by www.moateaching.com.
Till now, we have seen how we can graphically represent a pair of linear equations as two lines. We have also seen that the lines may intersect or may be parallel or may be coincident. Let us now study each case one by one. First, consider the example of Akhila going to fair and playing games and taking rides. We had two equations, y equal to half of x and 3x plus 4y equal to 20, whose graph came out to be two intersecting lines which intersected at the point 4, 2. This implies that the point 4, 2 lies on both the lines. Also, 4, 2 is the only common point. So we conclude that there is one and only one solution for this pair of linear equation in two variables, and that is 4, 2, where 4 represents x and 2 represents y, implying that Akhila had 4 rides and played 2 games in the fair. Also note that a pair of linear equation in two variables which has a solution is called consistent pair of linear equation. Since equation 1 and equation 2 have a solution, so equation 1 and 2 are a consistent pair of linear equations. The second case is when the two lines coincide, like in example 2, in which we had to find the cost of each pencil and each eraser, and two different situations were given with which we had these two equations. The graph was coincident lines. By now we know that solution of the equations are given by the common points. The coincident lines have infinitely many common points, so the given equations have infinitely many solutions. Also, we had seen that the pair of linear equations here are equivalent, because if we take out 2 common from the second equation, we get the first equation. So we conclude a pair of linear equations which are equivalent have coincident lines in graph and have infinitely many distinct common solutions. Such a pair of equations is called dependent pair of linear equations, which are also consistent as they have a solution. Actually, they have many solutions. The third case is when the lines are parallel. We had already drawn the graph of example 3, these two equations where the two rails were represented by equation 1 and equation 2. Here we can see that the lines are parallel, so they do not intersect at all, and the rails do not cross. This also means that the pair of equations has no common point. That is, the equations have no common solution. A pair of linear equations which has no solution is called inconsistent pair of linear equations. So we conclude that The above pair of linear equations do not have common solution and hence they are inconsistent pair. Whenever you see a graph of pair of lines which are parallel, means the lines are inconsistent and they do not have a common solution. It is not always practical to find by graphical method whether the given pair of lines are intersecting, coincident or parallel. So we have another method. Suppose we have the two equations, then the lines will be intersecting if a1 by a2 is not equal to b1 by b2. That is, ratio of the x coefficients is not equal to the ratio of the y coefficients. The lines will be coincident if a1 by a2 is equal to b1 by b2 is equal to c1 by c2. That means all the coefficients are in the same ratio. Actually, the lines will be equivalent. And the lines will be parallel if a1 by a2 is equal to b1 by b2 but not equal to c1 by c2. Let us now recall and sum up all the study till now. If the lines are intersecting, they have one solution and they are consistent. If the lines are coincident, they have infinitely many solutions and they are consistent and also called dependent lines. If the lines are parallel, they have no solution and they are called inconsistent lines. Let us read the question. Check graphically whether the pair of equations is consistent. If so, solve them graphically. Since we have to solve the equations graphically, so first step would be to draw the graph of equation 1 and 2. For that we start with equation 1, x plus 3y equal to 6, 3y equal to 6 minus x, y equal to 6 minus x by 3. Let us draw the table now. For x equal to 0, y is 2. For x equal to 6, y is 0. Similarly, for the second equation, we get the following expression after solving. And now, corresponding to x equal to 0, we get y equal to minus 4. And for x equal to 3, we get y equal to minus 2. Now let us draw the graph. We plot the points for the first equation, that is 0, 2 and 6, 0, and join them. This gives us the equation of the line x plus 3y equal to 6. Similarly, let us plot the points for the second equation. We plot the points and join them. We observe that there is a point 6, 0 common to both the lines. So the solution of the given pair of linear equation is x equal to 6 and y equal to 0. That is, the given pair of equations is consistent. Finally, in the answer you write that solution of the pair of equations is 6, 0 and the lines are consistent.